Okay, good morning class. Welcome again to the sessions on computer communication network. If you recall, yesterday we have started with chapter number 1, that is data communication. Let us recap a bit within 2 to 3 minutes and let us see what we have seen yesterday. Next. So what we have seen is what is a network, how a computer connection network is formed and how data is then exchanged. Then we have gone for layered communication. That is, whenever we go for transfer of data from one node to the another node, how that entire communication is established with several, layered architecture or within several layers, where one particular communication task is divided into or is conducted via several layers. Then we have seen the next first model for computer communication network suggested, that is nothing but our OSI reference model. We have seen different 7 layers, started from physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the last one nothing but application layer. So we have seen brief overview of what exactly the role played by each of the layer. Today we will focus more on what are the responsibilities of each and every layer available in the OSI reference model. Then we have seen just the overview of the TCP/IP protocol, which is the actual protocol which defines how the communication is established, what are the different protocols at each of the layer. Followed by we have seen the OSI versus the TCP/IP. So we have just gone through the comparison between how an OSI reference model layers and how the TCP/IP layers are there. What we have seen is there is nothing much difference. Only thing is in TCP/IP, 2 layers that was present in OSI reference, they were not there in TCP/IP. That is, session layer and presentation layer is clubbed along with some part in the transport layer for session layer, and then remaining presentation layer is combined with the application layer. Followed by we have seen the network topologies. So what we have seen is there are different nodes being taken part into the network. How those nodes are interconnected with each other. So depending upon the orientation, the layout, the way they are connected with each other, there are 4 categories of network topologies. It starts with mesh, bus topology, ring topology, and last is nothing but the star topology. So these are the points that we have discussed. Now today what we will do is we will get started with the OSI reference model. So these are the summaries of network topology. We have already discussed this out. There's 4 topologies. What are the advantages and disadvantages of each of the topology over each other. Next. So let us get started now with those 7 layers and individual tasks that every layer has to be done for the OSI reference model. Now the first and foremost layer that we'll start with is nothing but the physical layer. As we have discussed about, this is the basic layer in a network communication, where the layer above physical layer is where the data is available in the form of zeros and ones. So whatever the data available in the form of 0 and 1, before we could transmit it over a communication channel, we just convert that particular data into an electrical form or in electromagnetic form, so that that data can be converted and travel over the communication channel. So it is the layer at which the data conversion will take place from zeros and ones into the electrical form. Now what this layer is all about, the physical layer coordinates the functions of required to carry a bit stream over a physical medium. So input to the physical layer is nothing but, or the data available at physical layer is nothing but a bit stream, that is strength of zeros and one, and how that zeros and one are transmitted over the physical media that this physical layer is responsible of. It also states different standards for the mechanical and electrical specifications. And lastly is nothing but physical layer actually responsible for communication of the data between two nodes, because two nodes will get connected with each other via a channel. So between two nodes, when a channel is present over there, immediate to next that channel, the physical layer will be responsible. So what we can say is physical layer is responsible for moving an individual bit from one node to the another, because ultimately between two nodes only a channel is there, and physical medium is the physical layer is at the transmitter as well as receiving end. Next. So this is how we can explain where the layer above physical layer is nothing but the data link layer. We have already seen under layer architecture that each of the layer, the role played is it accepts services from the above layer and then pass that information to the next layer. So what is happening here? The physical layer is here, where the data bits or data streams are available in the form of zeros and one, and those zeros and ones need to be transmitted or need to be sent over a transmitting medium. So what is done here? Physical layer accepting data from the data link layer and transmitting over a transmitting physical medium. Now what are the physical layer concerned with? What exactly the physical layers parameters or values are? So what exactly it does is type of transmission medium. Physical layer is concerned with what kind of transmission media that we are going to select, what medium via which the data is going to travel. So it could be twisted pair, it could be a coaxial cable, it could be a optical fiber, or when we go for wireless communication, it could be a air as well. So the transmission media, it could be a physical wired connection or a Wi-Fi connection or and wireless connection. Then what is done here is, we already discussed at physical medium or at physical layer, data is available in the form of zeros and ones. But that data, when we pass on certain medium, obviously it need to be converted at several voltage level. So beta representation here is actually done as at different levels. And obviously when we are transmitting the data, that is bit stream, in the form of zeros and one, we are most concerned with what shall be the speed of operation, and that is why the data rate is one of the parameters considered in the at the physical layer. And lastly, we need to have the synchronization. That is, whenever we are transmitting the data will be transmitted in the form of the data available is in the form of stream of bits. So whatever the sender sends and the receiver receives that information, there has to be a synchronization, and which is achieved via synchronization bits. So that is all about how physical layer parameters are concerned. Next. Then immediately the layer above the physical layer is nothing but our data link layer. So what data link layer does? At the physical layer, the data is available in the form of bits of zeros and ones. But once we go one step ahead, what we do is we convert those bits. Rather, at physical layer, the data is available in the form of bit stream 0 and 1. But at data link layer, the parameter would be the data available in the form of several frames. So what we do? We divide that stream of ones and zeros into several groups, and those groups here called as a frame. Obviously, why we go for frames? Because if you are transmitting a huge data, there will be a bulk amount of information available in the form of 101010 stream. And if at all any kind of error that could occur into the transmission, we have to send all the data for that particular stream of zeros and ones. So instead, what do? We divide that entire data into several frames, so that if at all error comes, we can identify that frame and then we can retransmit only that much of frame. So the job will become more and more easier, and that task is actually done by the data link layer. And that is why if we go for responsibilities that are there at physics data link layer are framing. So first thing that is done at data link layer is the information available in the form of ones and zeros is converted into number of frames. So that is nothing but responsibility called as framing, followed by physical addressing. So what we do here is, as there are two nodes interconnected via one particular channel, but there is not only two nodes connected to the network, there will be several other nodes, several other systems connected to the channel. So what we do, we start giving addressing, or we start calling each of the node by its physical address, and that is also done at the data link layer. Secondly, the third parameter or third major role played by the data link layer is the flow control. Now why flow control is required? Because there are several nodes connected into the network. Not necessarily all nodes are of same specification. Now let me give a simple example. There may be some devices which are running at certain X speed, and there will be some other devices which are running at Y speed or Z speed. So each and every device that is connected into a network, so that every node will be running at different speed. And whenever that device is running at different speed, different clock cycle, obviously the speed of operation, speed of data processing as well as transmitting and receiving will be different. So whenever those devices are part of a network, obviously one thing we need to take care that if communication is established and the transmitting and receiving mediums or transmitting and receiving nodes are running at different speeds, we cannot transmit the data at certain or any specific requirement of that nodes. So what we do, what we have to do is, rather we have to focus on flow control. If devices connected to the network are of high speed, obviously flow control rate need to be increased. If low speed devices are there, accordingly the flow control has to be achieved. So controlling the flow of transmission of the data is also the responsibility of data link layer. Followed by error control. Obviously what we are doing is we are transmitting the values of zeros and ones only. So obviously there would be some kind of transmission error. So that error control is also the responsibility of data link layer. As at data link layer we will be going for framing of data. There will be separate frames of zeros and ones, so it will become more easier to identify error occurred in several frame of data. Let me take example. If there is a frame of 8-bit data, so identifying error in 8-bit will be much more easier than identifying error in thousands of bits that we are transmitting at the physical layer. So what is done is, at data link layer we go for framing and we select the framing as per number of bits, and therefore it becomes easier to control the error. And lastly is nothing but the access control. Let me see, data link layer is one of the most important layer available in the OSI reference model. It also has to focus on, concentrate on the access control as well. Now what do you understand by access control? Whatever the mediums that we are going to use within two networks, or say whatever the communication channel that we will be using, it may be a common channel between two nodes, or it may be a dedicated channel. If a dedicated channel is there, or if two nodes are connected like this and if there is a single path available, if dedicated channel is there, obviously there is no need of access control, because two channels connected with each other via two nodes connected with each other via a single dedicated channel, no need of access control is required. But if there is a path or there is a communication channel which can be accessed by several nodes, And then obviously if this node is communicating with that node with using same channel, if another two nodes want to get involved into the communication, they have to use again the same channel. And that is why we have to define a protocol, we have to define a standard for who is going to access that particular medium. That is, if common channel is available between different nodes, we must intervene in between and find out that who is going to access that particular channel. So data link layer has to do that role as well. So in short, what data link layer has to do? Framing, that is formation of group of several bits. Physical addressing, identify the nodes. Flow control, maintain the flow according to the nodes which are participating in the network. Error control, if at all any error occur in the transmission, it need to rectify it. And then last is access control. If common channel is available, we have to make sure that the protocol will take care of who is going to access that particular channel. So this is what the responsibility of data link layer is. Next.